What if we are given an equation? How are you going to identify if the given equation is a function or not function? The process to do that one is we have this one. We solve in terms of y. If it yields a unique result, it is a function, meaning we will solve values of x in terms of y. So to do that one, to illustrate, we have this given example. For example, we are given an equation y is equal to 2x plus 1. You will identify this if it is a function if we will substitute values of x and it gives you values of y, which is only 1. So for example, let's say if x is equal to, let's say if x is equal to 0. Where did I get this 0? I just represent it. So it's up to you what values of x do you like to substitute it in here, and it will give you unique value of y. If any value of x will give, if you evaluate and it will give you two values of y and more, then that is not a function anymore. But if all the values of x, if you substitute it in here, if all the values of x that you can think of, if you substitute it here, it gives only one value of y, then you can say that this is a function. Let us try 0. So if we replace x here by 0, y is equal to 2 times 0 plus 1. Y is now equal to 2 times 0 is 0, or we could cancel this already. Y is 1. So we have y is, if x is 0, y is 1. So in here, you can say that this is a function. What if we say that if x is equal to 1? So let us evaluate. So y is equal to 2. Instead of x, we replace it by 1. 2 times 1 plus 1. So y is equal to 2 times 1 is 2 plus 1. So y is equal to 3. Again, we are given our unique value of y. So what if we have x which is equal to 2? What will happen? Y is equal to 2. Instead of x, multiply it by 2 here. So 2 plus 1. So y is equal to 2 times 2 is 4 plus 1 is 5. So again, all the values of x that we can think of, or can you think of other values of x that will give you two values of y? None, right? So all the values of x that you can substitute or replace it in here, it will just only give you one value of y. Therefore, we can say that this equation is now a function. If you are not satisfied, we can graph this one using this ordered pair 0, 1, 1, 3, and 2, 5. So this is the graph. So the graph 0, 1, 1, 3, and 2, 5. So as you notice here, using the vertical line test, it only passed the graph only once. So again, this is a function. Let us take our example number 2. What if we have this one? Y is equal to square root of x plus 1. So let us evaluate. So if x, let's say if x is equal to, let's say 3. Y is now equal to square root of, instead of x, replace it by 3. So 3 plus 1. So y is equal now to square root of 4. So y is now, what is the square root of 4? It's either positive 2 or negative 2. In here, class, you notice that it gives you two values of y. So first attempt in placing values of x, automatically it gives you two values of y. This, you can say now that this equation is not function anymore, because one value of x, if you substitute it in here and it gives you two or more answers of y, then automatically the whole function will not become a function anymore. Okay, what if we have x is equal to, let's say we have 8. So we have, if x is 8, so y is equal now to square root of 8 plus 1. y is equal to square root of 9. The square root of 9 is either positive or negative 3. Again, we have two values of y if we have value of 8. So, meaning, this is not function confirmed. And another one, if we have x is equal to 15. So, what will happen? Y is equal to square root of 15 plus 1. So, y is equal to square root of 16. Y now is equal to positive or negative 4. So, again, if we also use, other than this, if we also use the mapping diagram, let's say we have this one, x is 3. If x is 3 as the values of x, and the value of y is positive 2 or negative 2, in here, you can see that the domain will be repeated for 2 and negative 2. Again, you would say that this is not a function. If we graph this, class, if we will graph this, the graph will look like this, right? So, we have 3, positive 2, and negative 2, 8, positive and negative 3, and we have 15, positive and negative 4. So, again, it passes, if you use the vertical line test, it passes the graph twice. So, therefore, this is confirmed, this equation is confirmed as not function. And let us take a look for our example number 3. So, for example, y is equal to 2x plus 1 divided by x minus 1. What will happen? Again, you think of values of x, any values of x, actually, that will not make the equation undefined, of course. So, in here, this is rational. So, we restrict values of x that will make this one, the denominator, 0. Alright. So, what if I say, I pick up x is equal to 0. Okay, can it give me value of y which is unique? So, for example, y is equal to 2 instead of x, replace it with 0, 0 plus 1 over 0 minus 1. So, y is now equal to, cancel zeros, positive 1 divided by negative 1 is negative 1. So, we only have one unique value of y. Right? Check. Function. Next, what if x is equal to 2? What will happen? So, y is equal to 2 times 2 plus 1 over 2 minus 1. That is equal to 2 times 2 is 4 plus 1 is 5. 5 over 2 minus 1 is 1. So, y is now equal to 5 divided by 1 is 5. Again, one unique value for y. And what if, let's say, x is equal to 3? What will happen? Y is equal now to 2 times 3 plus 1 over 3 minus 1. Y is equal now to 6 plus 1 over 3 minus 1 is 2. 6 plus 1 is 7. 7 divided by 2 is y is equal to 3.5. Again, it gives you unique values of y. So, therefore, since there are no result which gives you 2 or more, then this is a function. Okay, if you are not yet satisfied, you can graph it and use the vertical line test. In vertical line test, it looks like this. So, we have 0 and negative 1. So, the point is here. And then 2 and 5. So, 2 and 5. So, the point of intersection is here. And 3 and 3.5. So, 3, 3.5, this one. If we continue this one for x is negative 1, negative 2, negative 3, the graph will continue like this. And if we continue to the right, 3, if the x is 4, 5, 6, the graph look like this one. So, it is a rational function actually. So, therefore, from this, also, it confirmed that this equation is a function. But the main for us to say that an equation is a function or not function, we stick to the process. Again, the process I've told you earlier is we solve in terms of y for easier way. Okay, so that's it for now. We will continue our lesson for piecewise function for the next video. Thank you for